Hey everyone, in the last video we were going to examine what the Modbus registers do on the Sol-Ark 15K. So I do have that spec sheet, although it's for the 12K, but that doesn't mean we're going to have the same registers. So what I'm going to do is I wrote a little hack that's going to hit the Modbus on my inverter, and I'm going to pull down every register we see. If it doesn't find a register, we just won't print anything. And I'm going to let it run, and it's going to go from 0 to 300, which is beyond the numbers that they give on that sheet. So here goes. And we are getting some responses. Okay, so I'm going to let this run, and we'll do a time warp, and I will be back in a little bit. Okay, so it actually took a couple of minutes to scan all those points, but we do have results. On the left is the register and the results. So let's take a look at the PDF document that I have, and let's see if some of these line up and make sense. Let's see. So the lower register numbers, those look like faults. We'll kind of skip over those. Find something more deterministic. The day active power looks like it's a good one. I already highlighted these, but the fault words, there's no faults right now, so those should be 0. Let's take a look at 60 and I got a better idea. Let's look at the grid voltage. That's something we can easily check. So going to, let's see, 150. Yeah, so they're in tenths of a volt. So 124.4 volts for L1 to neutral. L2 to neutral is also 124.4 volts. What is, let's see, 152. L1 to L2, that should be like 240, and it is 249.8, which makes sense because if it's pushing to the grid, it's going to be a little bit higher than 240. So good, we're getting real numbers here. Let's look at some other ones. All right, so I pulled up the trusty MySol-Ark app, and let's verify some of these values. So the state of charge for the battery is 184. Switch back here, and I'm showing 58%, and according to the document, yes, it's per percent. There's no tenths. It's not a tenths of a voltage type thing that they put into an integer value. It's not fixed point or anything like that. It's just straight up 0 is 0% and 99 is 99%. So that's right. I am at 58%. And let's look at another one here. So currently my modules are producing about 6,433 watts. Now, according to this document, they only show 2, but I think 188 is also available. This is for the Sol-Ark 12K. I have a 15K. So let's take a look at 186 and 188, and they should add up to the total of 6.4 kilowatts. So 186 is 2,633. Okay, 2507 for the next string, and then for the third string, which I assume it's not in the document, but it looks like 180. That's it. 188 is 26, and there's your 6. Well, it went up a little bit, 6.5 kilowatts roughly. So that is correct. The other one that's on here, battery output power is 190. The app is showing roughly 5.6 kilowatts charging the batteries, and in 190, it looks like these are in tenths. So that's also correct. 5.9 kilowatts. All right. So let's look at the grid external total power. How much am I taking in from the grid? According to my app right now, I'm not taking anything from the grid. This is a trickle of 49 watts, which is typical for the Sol-Ark. And that is item 170. And we are showing for 172, 46 watts. So the app's a little bit off, but the app only updates every 5 minutes. The real-time value is 46, 49. It makes sense. I'm also showing right now the home is drawing only 573 watts. I don't have anything on except lights in my computer here, stuff like that. Let's take a look of where that would be. Maybe load side, total power. It's a little confusing here. We also have external. I see values for external. Those are probably the current transformers that we have. I'm curious to see how those line up. Okay, let's look at the load site. Load site total power is item 173, and not 173, it's 170. Yeah, that's exactly the same, 573 watts, and that's what I'm showing here. Okay, so then grid external total power we looked at. Inverter total power is 175, 531 watts. That makes sense too. So, what's one other sanity check? Let's take a look at the battery voltage and current. That's an easy one. Oh, okay. I didn't highlight it. So 183 and 191. It's in hundredths of a volt, so 53.8 volt or 53.9 volts. That's what I am showing on the app as well. We are charging the battery, so that makes sense. And then for the current, that's 191. That's in hundredths also, so that can't be right. Oh, that's output current. I don't know what that value is. Showing 53,891. All right, so it's a little confusing with the battery. They have a lot of parameters, but I know the voltage is right. The state of charge is right. The watts is, or the power, it looks like there's a typo in the document. Maybe it's not tenths, it's hundredths or whatever. But what I'm going to do is I'm going to rewrite this. I'm going to refactor the app, I should say, and assign names to these registers, and then start printing out in real time and seeing if they make sense and seeing how accurate the document is. I mean, I don't need all of these. Load frequency, for example, is 192. I don't know if I really need that, but 59.95 hertz, and that's correct. They list that. They actually list. They have the load frequency and the inverter out frequency, which is 192, 183, and obviously they should be the same. Hundredths of a hertz, so we would take this number and divide by 100, so we get 59.95 hertz. So that is pretty damn close. So anyway, let me do that and come back. I'll make a list of the required registers I want for this application and see what it looks like. So I'll be right back. Okay, a couple hours later, time warp. The values look good. The serial number was spot on. All the strings are correct. Load total power. I actually went into the app and I was able to line up what is what. Some of the names are slightly different, but that's okay. My daily PV power, you see that on the app as well. It resets every day. So, we had a lot of rain today, but 21.8 kilowatt hours. Voltage is right. The external CT power is very low because I'm not pushing to the grid right now. Totally correct. And I broke out the fault words. I have no faults, so it's 0. So this is a good start for a little application with HMI on it and some gauges and stuff that you can look at. I'm not sure what else more I would need, but that'll come, that'll make itself known as I do my development. So there you have it. This is doable. The Modbus does work on the Sol-Ark, not the battery Modbus. Not the battery uses CAN. Take that back. There's 2 Modbuses on the Sol-Ark. There's the one that it uses to communicate if you're going to run 3-phase or if you want to run in parallel to get 30 kilowatts, 215s, single phase. And that's how they communicate with each other. They would communicate over the Modbus. I don't know what those value. I'm assuming it's the same register values that these are, but I don't know. But I didn't hook up to that. I hooked up to the other one that they said to use. It's strictly for monitoring, and that's what these are. And by the way, it is strictly for monitoring. There's nothing to control from there. There's no, if you're familiar with Modbus, there's no coils to control. There's no, you can't set any registers. I tried and nothing happened. So I will save you the pain of trying to do that. And that's it for now. I am going to, for the next video, I'm going to start exploring what types of boards. I have some ideas. For the board to use, like with a display and whatever. I'm leaning towards something that's not Raspberry Pi based because the power requirements alone, and something simpler. So it would either be a bare metal system or it'll be something with an RTOS. I would prefer an RTOS because bare metal is, I don't have to, there's a lot of shit I don't have to write myself, but an RTOS would be great. There's free RTOS, there's Zephyr, what's the other one? Embed, I think. Anyway, I'm going to try to come up with an open hardware solution. Arduino has one that looks promising, although I can't stand their development environment. STM looks promising. They come with a display and a touch screen. There's a few other ones out there. I'm going to look at those, and when I decide one, I mean, you can let me know. Do you think I should go through the pros and cons of, and there's plenty of videos out there for that, to go through the pros and cons of every display and microcontroller, microprocessor combination. It's definitely going to be ARM based, 32-bit based. I am not going to do an Arduino 8-bit controller or PIC 8-bit controller. No way. No. 32 bits the way to go. I prefer ARM. I'm very familiar with ARM. It's very easy to use. It's powerful. Something with Cortex on it. It doesn't have to be multi-core, although many of them are. It doesn't need an MMU because we're not going to do Linux. So right now I've dialed it down to like 3 possibilities. So anyway, I will get back with that